Good morning, interweb. Spec Biolog 2. In the last video, we kicked off the series by deciding upon our kingdoms. In this video, we're going to start designing one of the body plans that exist within this mixotrophic kingdom. Should be good crack or a total disaster. Who knows? Let's go. So to peel back the curtain a little bit, I kind of already know what I want to do today. I realized in the last video I said I'd be working everything out on video here, but being a complete novice, it would be a terrible idea on my part to not have any sort of plan coming into this. That would just be a recipe for just utter disaster. So over the past number of months, probably year plus at this stage, I've been kind of sandboxing ideas. So I just want to kind of reveal some of that, I suppose, and explain how I got to where I am at the moment. So initially, the body plan, the mixotrophic body plan that would give rise to the charismatic megafauna on Kretak was going to look something like this. Basically a trilobite looking thing, bunch of segments, 3 compound eyes, biramus limbs. That's a limb with another limb on it. Very delightful. Now, I'm not sure if you can see the problem with this, but I suspect some eagle-eyed viewers would look at this and be like, wait a minute, that looks an awful lot like Biblaridian's work. And I would concur. I'm sure we've all experienced this where you kind of like adopt a new hobby because you get inspired by someone, and invariably all of your early endeavors in said hobby are basically just wholesale aping what other people do. That's kind of the common beginner track. And this very much was that. It was just me looking at Biblaridian and being like, I don't know what to do outside the context of Alien Biospheres, so I guess we'll just do Alien Biospheres 2, Electric Boogaloo. And that was fine for a bit, but eventually I was like, I need to try and like blaze my own trail here. But as a novice, it's kind of hard to just kind of dream up stuff without, years of knowledge behind you. So I did what I think is a very common Spec Bio beginner tactic. Instead of copying a crater, I just went ahead and copied Earth. Earth-shattering, I know. So I went on a mission to try and find basal sort of organisms on Earth that I can kind of adapt and modify for this project and use as a body plan. Notable in this was I watched the entirety of Professor Dave Explains Zoology playlist. I'd highly recommend this for newbies. He basically has a single video on like every phyla and then some. It's great. Cannot recommend this highly enough. Links in all the usual places. So I was watching his video on Periphery, sponges. Can't get more kind of basic than that. And that led me to discover this fella, Chondrocladia. The ping pong ball sponges. And yes, this is a peripherum, which is just kind of mental that it's a sponge. Crazy looking thing. It's a carnivorous tree sponge. And the basic idea is that it has these inflatable bubbles that are covered in these tiny spicules, like little hooks, that it uses to trap like little crustaceans that float by, I guess, on the surface, and then it like consumes them. I saw this and I was like, okay, well that's really basal, and also that seems rife to turn into a mixotrophic body plan. These bubbles could do double duty. They could be photosynthetic surfaces and surfaces to capture prey. So I was like, I'm going to work with this. So that's what we're going to do today. We're going to try and work with this and come up with something cool. Very un-Alien Biosphere, so hopefully, we're off to a good start. So the plan, we are going to come up with some sort of ping pong ball tree thing, morphology to be determined in this video. Something vague like that. I hope my chicken scratch makes some semblance of sense here. This bio is going to be a mixotroph. Gains energy from the sun and from consuming living matter. Cool. Now, the immediate thing that occurs to me is that we could have a very early split occur where it functionally, or its descendants lose mixotrophy. Some go full autotrophs, becoming our pseudoplants. Some go full heterotrophs, becoming our animals. That sounds really cool. So something, I guess, like this. So one branch goes full autotroph. That will become our pseudoplants. Another group over here will be our heterotrophs. Those will become our charismatic megafauna. And some groups will retain their mixotrophy here. I don't want the mixotrophy to be much of a focus in the modern world. I'd much rather have it be an ancestral state that we use to generate kind of cool scenarios. We're not going for like mixotrophic elephants. That's just not going to happen. It's not realistic. But I guess we could retain some of the mixotrophs, and I could easily see them becoming like the equivalent of coral or, sponges, that sort of thing. God, my handwriting is terrible. No, so this is all fine and cool, but this is weird. Like, hella weird. Like, not only are plant-like organisms and animal-like organisms in the same kingdom. The body plan is essentially synonymous with the phylum, right? So this means that at least some plants and animals are in the same phylum. Like, that's wild. Like, wild. So wild that I'm inclined to maybe downplay this a little bit. So, note to future Edgar, we should make the pseudoplants be pretty small. Maybe grasses, shrubs, that sort of thing. And we should make our true plants be large. So like redwoods, that sort of thing. Because it's a bit weird to have like a xeno pig or a xeno elephant and then your xeno giant redwood be all of the same phylum. It's a bit on the nose. Whereas doing it this way, you kind of hide the weirdness in plain sight in a way, which is kind of a bit more interesting to me, I suppose. But yeah, that's weird. That's very weird. Now, I sought some advice from Bib on this. Now, he was of the opinion that this sort of post-Cambrian explosion, because most of the body plans, we kind of think of them as being like Cambrian explosion body plans. This post-Cambrian explosion loss of mixotrophy and specialization into sort of the more normal, air quotes, trophic modes was, again, very, very weird. And his opinion was that really, and I'm paraphrasing here, so all errors are my own. If I misrepresent, I'm really sorry. But in a nutshell, he was like, this is kind of too late to have that sort of diversification happen. Really what will occur is that way back in time, like way before this chap was even a thing, there would have been some sort of like, you know, unicellular, tiny little microscopic ancestor, like a bit like a quanoflagellate, I take it, something like that, who was mixotrophic. And then a really early split there will be into something that still looks, you know, a tiny little microscopic thing, but the split would be, this would be an autotroph and this would be a heterotroph, right? And then, you know, eons later, we finally arrive to this chap, which probably makes the most sense to do, but we don't get this kind of cool scenario. So as a means of kind of like, I guess, meeting it halfway, what happens if we say that this body plan is pre-Cambrian? So the equivalent of kind of like an Ediacaran organism, like all of these boils. And the Ediacaran, as far as I can remember, it's the period before the Cambrian. And we just get hella weird, very, very kind of basic organisms in this time. So basically the idea is to sell this kind of strange setup, push the body plan back as far as we can in time without losing the ability to do this kind of switch up in a, you know, macroscopic multicellular state. So I think that's a fine idea to do. It's again, very speculative. It's a bit hand wavy. I'm sure I definitely will get feedback in the comments about this, but we want to kind of think of this organism as being like Ediacaran. And we'll put it in commas because obviously like that's an Earth term and not a Cretac term. Right, with all of that in mind, let's design this fella properly. Right, so I have here a sort of body plan checklist of all the kind of most important things I guess one should consider when designing a body plan. So I guess, yeah, we'll just go through this one at a time and hopefully we'll end up with a cool critter at the end of it. So we'll start with motility. This is pretty simple. Is the organism sessile or is it motile? Does it move or does it not? Based on everything we just talked about, the answer is clearly it's sessile. Not much to discuss there. Next up, we want to consider symmetry. Is it asymmetrical? Does it have radial symmetry? Does it have bilateral symmetry? All that fun stuff. This fella is screaming radial symmetry at me, so we'll go with that. It is going to be radially symmetric, but I guess we need to think about number here. Like, is it 3-sided radial symmetry, 4, 5, 6, etc.? I like odd numbers, so I'm gravitating towards 5 or 7 or something. Let's say 7-sided. Yeah. Now I have to try and draw a 7-sided polygon. Sure, there's a 7-sided thing. So we're looking down on the kind of stalk part. 7-sided symmetry. And we skip to locomotion here for a second. Obviously, it's not locomoting, but we want to answer the question about limbs. Does it have limbs? I think the obvious answer should be yes. So I'm assuming it's going to be like seven limbs per segment. So you'll have limbs coming off here. Again, top down, right? How the artistry is just chef's kiss. Off the chain right now. Now, segmentation. We're going, again, thinking Ediacaran. Along those lines, I would say no segmentation, because segmentation is, I think it's correlated with more complex body structures. And yeah, Ediacaran, not very complex. So I'm drawn to non-segmentation, but God, segmentation is just so kind of easy to work with. You have all these different segments that you can collapse down and specialize, and yeah, I'm going to say segmented just because I know how to work with that basically. And also remember, we're getting our plants from this body plan, or at least some of them. So if you make these segmented, they can contrast with like more standard non-segmented plants in our true autotrophic kingdom. So that would be, I think, a good idea. Yeah, we need the complex body patterning for our animals. Bit of contrast, cool. Yeah, so let's say it is segmented. So the question is, how many segments? So we're going to have some sort of stalk type structure, something like that. Here's the floor. Oh, and actually skipping ahead to like all of this, gas exchange, nutrition, excretion, renal system, all that sort of jazz. Ediacaran biota, we don't really find many body cavities going on there. And remember, body cavities on plants, pretty weird. So it would probably be a good idea not to have a body cavity in the body plan and evolve it later. So I guess we won't have this sort of like central bubble thing. So we can just make it just a stalk. Just one big old stalk, one segmented stalk with bubble arms coming off it. So let's just say, I like odd numbers. Let's just say we'll go 5 maybe. And we can always change it later if we need to. There we go. There's like kind of 5 segments on that. Okay, yeah, something like that. So we'll say segmented and yeah, 5x, 5 of them. Oh yeah, and these arms. So just have the arms coming off somewhere around the joints. Doesn't actually matter. Let's just say on the joints for now. I'm not going to draw all 7 of them because I just literally don't have the artistic skill for that. So I guess something like this. Sure, something like that, except, obviously 7 of them per segment. Okay, next up. So we got all of that done. Okay, gas exchange. In essence, what sort of circulatory system does our body plan have? Again, thinking Ediacaran, I'm thinking no circulation system or no circulatory system, and the gas is exchanged just by diffusion through the skin. And in particular, through the bubbles. So we should probably start thinking about the bubbles. 1 bubble per arm, maybe? Maybe that's a good idea? Yeah, I could see that. Let me draw just a circle. Hold on. Cool. Yeah, something like that. So just gases from the surrounding water will be absorbed through these bubble structures primarily, but I suspect the whole organism will be involved with that. Okay, nutrition. So we said no body cavity. Very Ediacaran. But remember the bubbles, yeah, they're used for catching prey and for being photosynthetic. So there's some sort of photosynthetic surface, which means they have a color, which means they are orange. All right, so it's going to have a pigment on the bubbles. Does the rest of the organism have a pigment? Probably not. Maybe just the bubbles. So we'll say the bubbles equals orange, because we said we wanted these orange pseudoplants. Okay, and they're also used for catching prey. So like on the surface here, like if I were to take a little segment here, all right, and make it big, magnify it, we'd have like the surface of the bubble, and it'll just be covered in these like hooked spicule type things like that. Prey comes along, gets trapped on the surface, and maybe some sort of membrane grows over the prey, trapping it, and it just gets diffused into the organism. Yeah, so we also have spicules. Or I guess they needn't be specifically spicules. They could be any sort of like hairy, like setae or cirri or whatever. Some sort of like Velcro-y type of structure. I don't think ultimately that matters. Specifying what they are specifically matters. Just that there is something there that traps prey. All right, excretion. Again, usually at this stage with an animal body plan, you'd be thinking, what sort of gut does it have? Does it have a blind gut or a through gut? We're going simple. We'll just say that there's no gut. We can evolve that later. Functionally, we're kind of very plant-like here. So any sort of excretion is just done through the leaves. And in this case, the leaves are, again, the bubbles. So stuff can come in and stuff can come out. Both solid and, we'll say, liquid waste. So there's no renal system, no nephridia, nothing like that going on. Just super, super basic and simple. Oh, and I should probably I'll just write diffusion here for the gas exchange stuff. Cool. All right. Nice. All right. Skipping to the fences here. Do we want armor or do we want no armor? Ediacaran, soft-bodied things, no armor is the way to go. In my opinion anyways. These surfaces are covered in little tiny barbs, so that could act as a form of defense. And we could adapt those later into, plates and things like that. So that's cool. No armor. Or actually just soft-bodied. Cool. Senses, mechanoreception, so sensing vibration. Again, those spicules can do double duty for us. And we're Ediacaran, we're plant-like, so no sight. This body plan is very much an exercise in not doing all the things. We could totally give it eyes. Like we could absolutely say at the end of these stalks, there's a little like photoreceptor or something. But I'm inclined to say no, and we'll just evolve eyes later. keep it as simple as possible to try and like make it feel like it's as far back in time as possible to make this whole mixotrophic switching thing feel a little bit more organic. Okay, and if I'm not mistaken, then we got the big one, reproduction. So, first question, does it reproduce asexually or sexually, or both? This is going to feel like a real non-decision, but I'm inclined to say both just because it affords us maximum flexibility. I've learned that one of the things that make a good body plan is its flexibility. So you don't want to like pigeonhole yourself too much, I don't think. So if we say both, that gives us maximum opportunity to specialize down the road. Some branches may remain asexual, some will adopt sexual reproduction, some could stay doing both. I think that's probably the wisest thing for now anyways. And because we have, at least in part, sexual reproduction, we start thinking about males versus females. So we go to this monoecious versus dioecious stuff. I always get this wrong, but monoecious is one house, means one house, and dioecious means two houses. So one house is where within a single organism, or a single organism is able to produce both male and female gametes. Everything is done in the one house, whereas dioecious is the opposite. A single organism is only able to produce male gametes or female gametes. You have a male and a female, basically. I know from a little bit of experience, again, the most flexible thing here is to say that the organism is monoecious. Monoecious, that's almost certainly spelled horrifically. I apologize for the handwriting, the spelling, the drawing. I apologize for the lot, folks. But yeah, we can totally take a monoecious species or organism and then have it, specialize down the road to become dioecious. Whereas I think the reverse is a little bit harder to justify. So again, in the interest of maximum flexibility, monoecious is the way to go, I think. So having decided upon monoeciousness or monoecy, that basically answers this: is the organism isogamous or anisogamous? And here I'm probably going to get stuff wrong again because I'm a novice, disclaimer, etc., etc. But isogamy is equal gametes. So any gamete can mate with, if that's the correct terminology, any other gamete. There's no distinction between male and female. And anisogamous is unequal gametes. So you have a male gamete and a female gamete, and only male and female gametes can come together to produce an organism. So if you're monoecious, you can't really be isogamous. That doesn't make any sense at all. If you're male and female at the same time, and there's no distinction between the gametes, well then, like, what even is going on? I think, anyways. So I'm going to pencil in anisogamy and then check my notes afterwards and realize how wrong I am. Anisogamous. Sure, that'll do. Next up, let's do external versus internal fertilization. I think this is also a no-brainer. It's in the ocean. I suppose I didn't specify that. I guess, that hopefully that's clear. We're in the ocean here. I'm assuming you'll do some sort of broadcast spawning, release gametes into the water column. Those gametes meet, fall to the floor, new organism. Brilliant. So I think external fertilization is the way to go. Internal fertilization seems way too specialized for something as kind of basic as this. External fert. I'm running out of room. Sure. God, the writing truly is horrific. And then final 2 points. Morphology and sex determination. So we don't need to worry about sex determination because the organism is both male and female at the same time. But later on down the road, we'll have to think about whether or not the sex determination is like genetic or is it environmental and the like. So that one's done. And so I guess the final thing, and then we're done for today, is to figure out the morphology. Like where are the gametes? And 2 locations stick out to me immediately. Maybe perhaps when it comes time to reproduce, some sort of structure forms up here, like a gamete balloon, which then bursts. Yeah, sure, that's an explosion. The drawing's so bad. But yeah, this like gamete capsule bursts and all the gametes are released into water column. So it could happen at the top of the organism, or it could happen on the end of the arms. So there could be some sort of like bulbous thing going on here. Kind of like that. Because, yes, I very much like that, because if I just give me a second to finish drawing all the things, I'll give a bit of color. Sure, something like that. Because what's eventually going to happen here is, I'm pretty confident, is that, some sort of body cavity will form here. These arms, like, will do some sort of tagmosis, fuse these segments together, and these arms will, like, kind of move forward, and eventually, like, they'll become, like, teeth, and grabby things and tentacles and all that sort of jazz. So having the kind of gametes be located here, it gives us, again, flexibility. Like in the modern animals, they could be like tentacles on the organism's face that are tipped with the reproductive cells. They could move into the mouth of a future organism. So I think it gives us more flexibility going forward. And I can't think of any other place to put them, really, other than just like, on the side of the stalk. But you kind of want to get these gametes, I think, as far away from the center of the body as possible. You don't want to have these gametes be exploded and then they just hit the center stalk and stay there. It's not much good. I think they should be as peripheral as possible. So I think that's probably what we'll do there. I don't even know what to call these kind of gamete tips. Gamete tips? I have no idea. Something like that, I guess. And that's it. A sessile, radially symmetric stalk thing with inflatable mixotrophic bubbles, I guess, on the end of 7 arms per segment. Yeah, not terrible. What's this? The guy learned how to draw all of a sudden? Yeah, no, I wish. But yeah, I can't draw, but you know who can draw? Vanga van Gogh, resident artist over here at Artifexia. He's going to be doing all of the artwork for the series going forward. And this is the first installment. This is our little body plan. Look how cool it looks. Just so much better than this absolute garbage chicken scratch. Really, really like this. And there's more. So for anyone who's not seen the previous series, World Builder's Log, links in all the usual places. TLDR, humans from Earth come to Kretak via these kind of like magical space portal type things. And yeah, this is what the space portal looks like. And check this out. There's a little dude down here. Look at him there. Look at him go. Just for scale. How cool is that? And there's even more. So we mentioned that on the next star system over from Kretak, there's an advanced alien race. They notice that the humans have come to be on Kretak. They pick up like weird energy signals from the portal. So, being an inquisitive bunch, they send over a bunch of surveillance robots to see what is going on and document what's happening. This is what the robots look like, and it's so dope. Absolutely love this. All artwork by Vanga. What a dude. Thank you so much, Vanga. Please go check them out, folks. Links in all the usual places. Now, final thing is we need a name for our body plan. Eventually, of course, the most important organisms will get names in a conlang, in a human conlang, but that's just like years down the road. So I think for now, the best thing to do is stick to your standard Linnaean nomenclature, your Greek and Latin names for naming all these organisms. Actually, not Latin. I can't stand Latin. Just Greek. We're just going to go with Greek here, folks. That makes me feel better. So as a thanks for watching the show, I'm just going to, devolve all of that to you guys. So please leave any name suggestions in comments. Just make sure that they follow standard Linnaean nomenclature, that they're in classical Greek, and that obviously they're descriptive of the organism. Other than that, have at it. Patrons, I'm going to give you the ability to have a final say on what names become canon. Just as an extra added thank you for keeping the lights on and keeping me off the street, which, I can't emphasize enough. I am very grateful for. So yeah, let me know. What should this dude be called? That's us. Massive thanks again to Vanga van Gogh. Links in all the usual places. Go check him out. And as always, a massive thanks to Biberidian. Everything I know about Spec Bio comes via Biberidian. He's been teacher extraordinaire. His input and advice has just been absolutely invaluable. None of this would be possible without him. So massive thanks. And if for some reason you've been living under a rock and you don't know who Biberidian is, you should go subscribe right now because the man is awesome. Links in all the usual places. So until next time, Edgar out.